Hi guys, welcome to a lesson of ordinary differential equations. We are discussing the significance of ordinary differential equations in contemporary sciences, and we discussed about a problem last time that was Newton's law of cooling. Today we are going to talk about free fall of bodies, right? So again, this topic is related to mechanics, physics, and we already have learned these equation of motions in our elementary physics classes, right? So we know that if a body that is falling freely from a distance or some height, let's say a daredevil jumper is standing on some building here, and it's going to jump with its parachute, and let's say that the height of the building is denoted by h, right? And the uh, devil is going to jump from the height h, right? So we know that in this situation, if we neglect air friction, we have the equation that is d square uh, x over dt square is going to be equals to negative g, right? Because the acceleration is going to be equal to the gravitational acceleration in this case, and this negative sign here, it just shows the uh, direction of the motion as it's going downward. And also we know that the gravitational acceleration is the direction is downwards, right? So this is a simple differential equation, second order. We can just simply integrate twice to get the result of this differential equation. But before that, we are going to talk about some initial conditions. So in this case, we know that the initial velocity, that is, we can say at time zero, is going to be zero because it's at rest, right? The body is at rest. And also the initial displacement, as there is no displacement, so we can write that x of 0 is equal to 0. And for this v0, we can write dx over dt, because this is velocity at time 0, so it's 0, right? Now we can just solve this differential equation. Oh, sorry, one thing we need to correct here. The distance is going to be h, because the initial distance, that is from the ground to the top of the building, it's h, right? It's the height. So now we can simply, or we can also call it as x naught, right? Initial displacement, initial position of the body. So now we can solve this differential equation. We call it as equation 1. So this implies that if we integrate this equation twice, we can write d times dx instead of d square x, or I should make this a step clear to, I should write it this way first, and then negative g dt squared. Now we can write this d square x as d times dx integral and negative g times dt integral, and then again dt here. So this d is going to cancel with this integral because it's anti-derivative, and here we are going to get gt plus a constant that is c1, let's say, times dt. So now again we are going to integrate to find the value of x, so it will be negative gt squared over 2 plus c1 times t plus c2. Okay, so now this equation is modeled, but we still need to find these C1 and C2 to make it a deterministic model. So we will exploit the conditions that are given, that is the initial velocity v of 0, or we can say dx over dt at time 0 is equals 0 because it's the body is at rest and it's going to jump from the top, and it is at rest, and then initial position is, that is x naught is h. So now we can plug in these values, or to make it more general, let's say that the initial position is v naught, right? So we are not just considering that this problem, we are generalizing it, right? So now we'll apply the initial conditions. First we can apply this condition, that is v of 0, that is dx over dt. It means that we are going to find dx over dt here. So dx over dt, we need to differentiate the equation, is again going to be negative gt plus c1, and we know that the initial velocity is v naught, so therefore negative g times 0 plus c1. This implies that c1 equals the initial velocity. So whatever the initial velocity is, that is c1. Then we have x of 0 equals h. So x of 0 equals negative g times 0 squared over 2 plus c1 times 0 plus c2. So we are going to get c2 equals, and it's equals to h. So we are going to get c2 equals h, right? Now we are going to substitute this these values in this equation, that is, we can call it equation 2. So now this equation 2 implies that x of t at any time t, the distance or the height, is going to be equal to gt squared over 2 plus c1t. C1 is v naught, so v naught t plus the initial position, that is h. Or sometimes you may see this as x naught, because this is the notation for the initial position, right? So this is our modeled differential equation, and by using this kind of differential equation, we can solve any problem that is falling freely under the influence of gravity, and we are neglecting any other forces, for like frictions and other forces. So this is the model differential equation, and now we can find the displacement at any time t. Let's say if they ask that, for instance, that the height is 100 meters, for instance, and they are asking that find the position at, or after 2 seconds, after 2 seconds. So we know that the initial velocity v naught here is going to be 0 because it's standing, the body is at rest, and it's going to jump from rest, right? So v naught is 0, h is 100. We can plug in the values. So x of 2 is going to be equals to negative g times 2 squared over 2 plus 0 plus 100. So x of 2 is going to be negative g. Instead of negative g, we can write its value. So it's prescribed as 9.8 meter per second squared. So this is going to be 9.8 times 2. This 2 is going to cancel with 1, 2. So 9.8 times 2, it's negative 19.6 plus 100. So the position of the body after 2 seconds is going to be 100 minus 19.6. That is 100 minus 19.6. It's going to give you 80.4. So after 2 seconds, it's going to be at the distance 80.4 seconds, right? So its position is going to be at 80.4 seconds. So initially it is at 100 meters above the ground. So after 2 seconds, it's going to be 80.4 meters above the ground, right? And if they ask that how much time it's going to take, how much time the body will take to reach the ground. Now we know that the distance is 100 meters, right? So he need to cover 100 meters. So x equals 100. He need to cover 100 meters to reach the ground, and initial velocity is still there, it's 0, and they are asking for time. Now let's see, one thing to consider here is we know that the body is moving downward, right? So conventionally, when a body is moving downward, we write its displacement or displacement as negative, with negative sign, because we are using the convention that when we said earlier that the gravitational acceleration is downward, that's why we uh, put a negative sign at the back of the value of the gravitational acceleration. That is, we write it as negative g. Therefore, we are going to use this convention here as well, otherwise it's going to give wrong answer. So this is very important, right? So it will be negative 100. So again, we have the formula that x of t equals negative gt squared over 2 plus v naught t plus h. All right, so this is negative 100. This is negative 9.8 divided by 2 times t squared plus v naught. Okay, v naught is 0 because the body falls from rest. So this term will be 0 and h is 100, right? So now this 100 we move on to left side, so it will be negative 200, and this 2 we are going to multiply here is going to be negative 9.8 t square. Again, now this negative and this negative will make it positive, and we can write it as 400 divided by 9.8 equals t squared. Now we need to divide this 400 with 9.8, so we are going to get t square equals 40.816, and then taking the square root of 40.186, we are going to get 6.34 seconds. All right. So this is the time that the body will take to reach the ground. That is it's going to travel 100 meters downward, right? So this was a pretty simple problem that we already are familiar with, but because we are discussing the significance of differential equations in our daily life and in physical problems and science, so that's why we are considering these kind of problems. And in the next class, we are going to uh, take some other problem. We'll talk about liquid height in a draining tank. So when a tank is draining, so the liquid height, we know that it's varying time by time. So we will discuss that, how it occurs, right? So thanks for watching the lesson. Thanks for your time. That's all for the time being. Thank you.